Hi everyone, my name is Brian and I'm the 3D print creator. In this episode we are going to talk about working with Simplify3D on the Vinci Pro machine. And the Vinci Pro machine is the machine here right behind me, and the software I have already opened and you can see it on my screen. Here we've got the build plate of the Vinci Pro, and this is the build plate as you can see it when you have installed the Simplify3D software on your computer and you have told it that you're working with the Vinci Pro machine, because it's a fully supported machine. At my build plate I already have a model which is one of the simple models from 123D design you can play around with, and I've chosen this model because, well, I can explain everything with this model. So here you can see the interface, which has a lot of repair possibilities. It shows you which model you are working with, because you can have multiple models on one build plate. It shows you what process settings you are going to use. And here at the right hand side it shows you some special interfacing possibilities, and I'll explain this later. So when we're looking at this software, and especially when we're looking at it to see what's better than the XYZ Pro slicing software, which we get for free at this printer, we have to take a look at the settings we can create which aren't possible when we work with XYZ Pro. Because in XYZ Pro we're pretty limited in the possibilities. And this software costs a lot of money and I've paid it full, so I didn't get it for free to make a review about it or something. I paid it in full. This software costs you $150 to get it working on your computer. When you bought this software you can use it for this machine, but you can also use it for a whole lot of other machines, because this software is pretty much the standard for high quality slicing software. And it's not only the slicing, it also controls the printer. So I don't need XYZ Pro to upload my files to the printer, like from Cura, for example. You can also use Cura as a slicer, but when you use that you need to upload your files in XYZ Pro. Now we're completely disabling the XYZ Pro software and we're doing everything from within Simplify3D. So we're going back to the model here. This is my build plate. There is a lamp on it and we can show what's possible with this software. To go into my slicing settings, I am going to click the process settings, because this is the processing, and when double clicking it I can go into my settings. Here you can see the simple the simple way of looking at how to slice this object. I can tell what my profile is, I can tell what kind of material I am using, like PLA, ABS, PVA or nylon. I can tell what kind of quality I want, because here I can select fast, medium or high quality. And this is only telling if I'm going to print with 0.3, 0.2 or 0.1 layer height, because that's all this is saying. And I can set my infill percentage. And on top of that I can choose to include a raft and to generate support. But I'm not able to set any other settings. But then when I go to show advanced, there is a lot more I can choose from. I'm going to make this a little bit larger, because then everything is on one line here. And you can see you've got a lot more options, and those are really a lot more than the options from XYZ Pro. So we'll walk over it one by one. Here we are in the extruder settings. We only got one extruder in this machine with only one tool head, because we don't have any other tool heads. And the nozzle we are using, if you use a standard nozzle for this machine, then you're using a nozzle of 0.4 millimeters diameter. And also when we look at the extrusion multiplier, this is set at 0.9, and this is a common thing for this printer. You can change it, but this is the good setting for printing with PLA. Then here we can set the retraction settings, and actually when you for the first time use this software, the retraction distance is set at only 2 millimeters, and this is the setting for how much the filament is pulled back every time. It doesn't have to spray out some filament from the nozzle. So when you're moving from one part where you have to print to another part where you have to print, then while this tool head is moving, this nozzle is moving, you don't want it to ooze some filament out. And here you can select to retract your filament so it won't ooze out. And the distance you're going to retract it for a Bowden extruder, and that's the type of extruder we have on this machine, is normally about 5 to 8 millimeters, and this machine works great with 6 millimeters. Then there is an extra restart distance, and this is the distance where the machine has to restart with printing filament. So it's in time when it has to print that the filament will come out at the correct time. And the fun thing is you can tell it to slow down, so it has to wait, for example now, 1 millimeter before it starts spraying filament on your model. But you can also give it the negative time, and sometimes you need a negative time because your filament is not ready yet to print out. So then you tell your nozzle to have some filament oozing out a little bit before it starts with the print. And this can really help you if you have some small gaps. Then you have your retraction vertical lifts, also a very important setting. With the vertical lift you can tell your printer to lower the bed every time your nozzle is going to walk from one path to another path, so it won't hit into your print, into your object. Normally I leave this at 0, but for very large prints, very high prints, sometimes I use a setting of 0.50 millimeters here, because then it will help me not to hit some walls or whatever in the print. And the retraction speed can be set here, and the retraction speed at 40 millimeters per second. I know that this printer works very good, so this is a setting I've played around with, and 40 millimeters gives very good results. Then you can set your coasting settings, and coasting means that before the nozzle goes to the end of your perimeter it has to print, for example when it has to print this circle, just before it gets to the end it stops printing, but the filament is still oozing out from the nozzle. And this is something you can set. Well, for example, I want you to have a distance of 0.2 millimeters where the print doesn't give pressure on the filament anymore, but still the filament is coming out, so this can prevent from small blobs. And you can also wipe the nozzle, but in this case you won't need it. Then we go to the layer settings. We have only one extruder, so normally this is the primary extruder. We can't set any other one because we only have one. Here we see the primary layer height, which is 0.2 millimeters, and well, actually this is the setting which complies to the medium setting we have set here. If I would have gone too fast, you see that now it's 0.3, and if I go too high it's now 0.1, but we wanted to do it at medium, so we leave this setting at 0.2. But you can change it, and then you can change what fast, medium and high, what those mean. So you can define that here. Then we have got the top solid layers. How many top solid layers do we want? Now, normally I want 3. Also for the bottom solid layers I will normally want 3. And for the outline layers normally you can have 2 or 3, which makes your object very strong. I leave it at 2. Now you can set your outline direction, and your outline direction is how the printer is going to print. Is it printing the outline of your object first and then the inside of your object, or is it printing the inside of your object first and then the outline of your object? And you will get the most nice prints when you select inside out. But sometimes when you want your inside to be very smooth and very good, then you choose outside in. So here you can choose whether your inside or your outside of your print will be very smooth or not. When you're printing very small parts, then it might be good to select print islands sequentially without optimization, because when you select this setting, then the islands will be printed one by one every time. So when you do that, it gives the islands more time of cooling down, and this will prevent your print from melting. And in the corkscrew printing mode or the face mode, your z-axis will continue to lower while printing. And when you choose this, your z-axis will continuously turn, and there will be a spiral made. And this spiral can only be one layer thick, of course, but it's a very strong spiral, and it doesn't have a start point and it doesn't have an ending point. So this is very nice to print with, because you don't see where the print started and you don't see where the print stopped. But you can have it only one perimeter thick, so this is something you should know. And also when printing in the face mode, you can't have any infill, which is also very important to know. Then you can set your layer height settings for your first layer. And this is a very nice setting. And this is also very important if you're working with some alternative build plates. Like I work with Buildtech. And Buildtech, your first layer, you shouldn't print it exactly on the same level as where you calibrated your printer. Because if you do so, then you can impossible get your print off your Buildtech because it sticks too good. So when you go a little bit higher than that, then you can easily remove your print from your Buildtech build plate. So I'm at 120% for the first layer only, and after that every layer will be on the correct place, but the first layer will be printed a little bit too high above the Buildtech surface. If you're printing on glass or on blue painter's tape, or you have to experiment which setting is the best for you. Then also the width of the first layer. This is how thick your first layer will be pushed out of the nozzle. So if you push harder on the filament while it's oozing out of the nozzle, then the thickness of the wall will be a little bit thicker, and this helps when your bed is not perfectly leveled to make sure that your print will stick to the surface. And I found out that with 120%, it gives a clicking sound sometimes on this printer, and that's because the extruder can't push that hard. But on the other hand, it works very, very well, and I know that it prints all the way a very good adhesion. So it's a great setting. You have to know that this printer suffers from a small problem, that your bed isn't completely flat. This is the reason why some people print on glass, for example, because glass is completely flat. In this printer, when you calibrate manually, then you can see that you can calibrate your 3 points where you have to calibrate the bed. But then when you're looking at the middle part, which should be exactly calibrated because you calibrated the 3 points exactly, then your middle part should be exactly good. And at this printer, I know this middle part has a small hole in it. And that means that, well, at the middle, things won't stick that good. But with this setting, I can make it stick, and I can make it stick very good. Then so you can also set your first layer speed in a percentage of your complete printing speed. So later on we're going to show that you can set your printing speed, but here we can give the first layer speed, and you can select what printing speed the first layer will have in a percentage to the normal printing speed, and I set it to only 25%, which is really slow, but this gives me a perfect adhesion from the material to the print bed. Then you can select your start points, and those start points you can select 3 types. You can say I want to use a random start point for all perimeters. Now the printer starts every time on another place in your print, and because it does that, every layer it goes higher and higher, it starts at another point, and now you can't see where the start point is. Sometimes when you print in XYZware, you saw the small line which raises up from the bottom to the top, and this is every time where the printer started. So this wasn't very nice and you have to send it away. With this setting you don't have to send anything away anymore. The downside of this setting is that the printer has to travel a lot with its head before it starts every new layer round, and that means that your print gets slow. So you can also choose to optimize the start point for the fastest printing speed. This gives the same result as in XYZware for Pro, because now your travel time will be the smallest possible time there is, but this can be that every time the print starts at the same place in your layer, and now you can see a small stripe on your print which gradually goes up. And also you can choose a specific location where you want to start the print every time and again. So now you can say, well, I always want the print to start at the back side of my object, for example, because when it starts at the back side of the object, whatever happens in the front is always a solid print. So I don't see this stripe which goes up. So you can choose whatever you want. I choose random in this case because I wanted to have a random start point. Then we go to the additions. Here we got 4 additions we can choose from. We can choose from the skirt and the brim, the raft, the oozing shield, and the primary pillar. And the best thing to show what's happening is to show it on the print. So this is the skirt and the brim settings, and I can go to all the settings, but I think this is pretty obvious what it does. So I'll show you what a skirt and a brim is. I click OK, prepare for the print, and then you see here I have to take a look at the bottom, because there you can see it. This black line you see something like here. This black line, this is my brim. This is where the printer starts printing material before it actually starts to print my object. And you can see it because also the color tells that it is my brim. Here it is this color and it's the skirt brim color. This is because then I know for sure that my printer has material oozing out of the nozzle when it actually has to start the print. So now I can set what to do and to have a brim or not. I usually use this setting, here we are, with the raft. So I use also the skirt and the brim and the raft. And the raft, I'm also going to show you, is the base layer where the print will be printed on. So here we have, I have to select the turnaround here. Now you see that the print doesn't start on the bed, it starts on the raft. So first there is a raft created, and then on that raft the print is created. And this is to create a perfectly smooth and flat ground where the object is printed on, and you can break this off very easy after the print is done. And I tend to use a raft every time I print because it helps me to get a really nice and smooth print. I go to the process settings again, and then we have the primary pillar. This is a great setting if you have more than one extruder in your printer, because then a primary pillar will be something like a pilar which is standing up, and this will be printed with one nozzle at a time. So it will make sure that your filament is oozing out of the nozzle every time it changes from one nozzle to the other. But as we don't have more than one nozzle on our printer, the primary piler will be ludicrous to print. We don't need it. And then there is the oozing shield. The oozing shield is also to stop the nozzle from oozing filament when we actually are printing on our model. So it can ooze something else in another location, and I'll show you what this is when I go to prepare to print. And you see that my print will be surrounded with something like the oozing shield. This whole purple thing you see here is the oozing shield, which is surrounding my object I'm printing. And the only reason it is here is because then the nozzle can leak filament in this oozing shield, and it won't leak filament in your object. I think this is a great setting if you have more than one nozzle, but we only have one nozzle, so forget about the oozing shield. And we go here to the additions and I turn it off. Then we go to the infill. The infill is how dense and how the structure on the inside will be. So we can choose no infill, then you will print only hollows. And you can choose an infill percentage, and then you will have something in the middle of your print, so your print won't break that easy. When you're printing an infill, your infill will be printed in our case with the primary extruder, because we only have one extruder, and we can print this on several infill patterns. We can choose from rectilinear, grid, triangular, wiggle, fast honeycomb and full honeycomb. And to go back to where we started once when we bought our printer, when we're using XYZ for Pro, we only have rectilinear and full honeycomb. Those are the only settings we have in our old software. So now we have a lot of more choices we can make, and for example triangular will give a very nice example of great printing speeds, because you can print a lot faster now, and strength, because triangular is really strong. Then we also can set our external fill pattern. This is for external surfaces, like things we have outside of our print. Well, we're not going to use this, so you can leave it on whatever you want. Then we have the infill percentage. It's the same slider as we have here on top. So here we can set our infill percentage, and normally I choose something like 15 or 20% for the infill. A little bit depending on what kind of material I'm printing. When I'm printing ABS, which has the tendency to warp, I will go as low as possible, but you have to do a compromise somewhere. So normally I tend with ABS to use 10 or 15%, and in PLA 15 to 20% infill. Then when you're printing the infill, it's great to have it overlapping with the original outline. So you're printing your perimeters for your outline, and you want the infill to overlap that, so the infill is very strong with the actual print. And this is the outline overlapping, and we can't set this in XYZ, but we have the complete control over it here. And at 15% this gives a very good overlapping, but when your infill has to be really, really strong, then you can choose 30% for example. Also you can set your infill extrusion width. This is how much the filament will be pushed out, so it prints the infill, and normally you leave this at 100%. But when you see that, for example, your infill isn't strong enough and isn't dense enough, then you can increase your extrusion width to make it more dense. And then we also have the minimum infill length. When it's lower than 5 millimeters, it won't print any infill. And you can choose not to print infill every layer. So you can say, well, I want only the infill on every second layer, for example. A very, very strong thing in this slicer is that you can include a solid every time where you want it. So for example, now it's set that every 20th layer will be a solid layer, and I'm going to show you what this means. This means that when we are going to print this, and I'm going down on it, now you can see here the orange parts are the infill. So when you see the orange parts here, those are the infill parts printed inside this spiral, which is the lamp. And now when I go up, you see here there is a solid part, and this is a solid layer. It's green and it tells you it's a solid layer. So now 20 layers after it, it's going to print infill again. And when it reaches the 20th layer, it will print a solid infill. So every time at the 20th layer, it prints a solid infill, which makes the part very, very strong without having to print it completely filled. This is a setting you won't use when you are printing with ABS material, because ABS material, when you have too much infill, it has a tendency to warp. But with PLA, it's a very great setting to make your part very, very strong. So I really love this setting for PLA prints. Well, we go back here. Now we had the infill. You can also choose the angle your infill will be printed at. And this is great if, for example, your object will be turned around a little to place it, for example, in a diagonal mode on your print bed for something which is larger than 20 centimeters. So then you can choose the angle in which the infill will be printed. Now we go to the support, and the support we can do a lot with. In another video I will show you how you can create your own customized support, so you can choose where to print support and where not to print support. But for now I'm going to use the general support generator, and here we can set it to print with the primary extruder. We only have one extruder, and we can say how much infill there will be, what the I don't know how to pronounce this word in English, the extra inflation distance is, how dense the support layers will be, how dense the infill percentage will be, how much print support there will be, well, every one layer, for example. So here we can set all the settings we want for our support. And when you don't do anything with this, then the supports are really, really good. I haven't played around with this too much, because the supports are very good when you don't do anything with it. There are also possibilities to draw your own support lines there where you need them in your print. And I'm not going to discuss them in this video, because this already is a very long video. But it's really great to draw your own support lines. Then we go to the temperature. You have two temperatures you can set, and you can set them over time, which is a great option. You have your primary extruder. Well, there is only one extruder, so this is always your primary extruder. The temperature identifier is T0. You can choose other temperature identifiers, but they won't work on our printer here, just because we only have one nozzle. The temperature controller type will be the extruder temperature, and we will set this to wait for the temperature controller to stabilize before it starts building. Now here you have your set points, and you always have one set point. Your first layer is your first set point. So at layer 1 I want the temperature to be 195 degrees centigrade. After that I can set another set point that I want, for example, at the 5th layer, that it starts to print at 200 degrees centigrade. So this can be very good if you know that your print after 60 or 70 layers will be very small. Then you can lower your temperature so it won't overheat your print. So here you can really set the temperatures for your printing. And you can also do that for your heated bed. So the temperature identifier for your heated bed will be T2, and it's a heated build platform temperature. You also want it to be stabilized before you start to build, and here you can set at the first layer, for example, that it starts with 60 degrees, and you can say, well, at another set point, that set point will be the 20th layer. When I'm at the 20th layer, it can go down to 40 degrees, for example. So now when I set this, then when the print reaches the 20th layer, it will lower the temperature on my print bed to 40 degrees. I don't think this is very handy, but it's possible to set this. Another thing which is really great, which you should really know, is that you can go higher than 90 degrees centigrade. So in XYZ for Pro, 90 degrees centigrade is your maximum temperature. Here you can actually reach higher temperatures, and I've printed ABS material with 110 degrees centigrade for my heated bed, which is really great. But I have to make a side note. I don't know what the reason is why XYZ or XYZ printing selected 90 degrees as the top temperature. Maybe it is because they know their hardware better than I know, and they're afraid that my print bed can catch fire, for example. So maybe at 110 degrees it's very dangerous to print. I really don't know, so I will urge you to keep an eye on your printer when you're printing with higher temperatures than 90 degrees centigrade. But I have printed myself on 110 degrees centigrade with ABS, and the result was magnificent, because now my ABS material was sticking way better to the print bed than it was ever before. So this is for the temperature settings. Now we go to the cooling. Well, you don't have that much to choose for when cooling with this printer, because this printer don't allows you to set the cooling, so you can't do anything here. We go to the G-code. Well, to be really honest, I don't know enough of G-code to tell you anything about these settings. My knowledge of G-code is honestly too limited to tell you anything about G-code scripting, and that also goes for the scripting part here. I don't know enough about it. Then when we come to the other settings, here is a very important setting. This is your default printing speed, and your default printing speed you can set very slow, you can set it very high. I tend to use 40 millimeters a second because I know that this printer likes to print at this speed without any humping, bumping, screaming. It does a very good job at 40 millimeters a second. Then we can set all other speeds in a percentage to this speed. So my outline underspeed goes to 70% of 40 millimeters a second. My solid infill underspeed goes to 80% of this 40 millimeters a second. And so here you can set, here you can tell your printer what the speeds will be when printing. Then here, so we can set our filament diameter, we can set our filament pricing. Well, my spools cost 22 euros a kilo. And here you can set the filament density, which is normally something about 1.25 grams per cubic centimeter. but I really would like it if makers of filament would give their perfect filament density, so you know what it is, because I really don't know it, and normally it will be around this number, but yeah, it can be different from different filaments. Then also there are some settings here, like the bridge extrusion multiplier, how much extrusion you want to have when printing bridges, the speed multiplier, so it goes from 40 millimeters to 50%, so it goes to 20 millimeters when printing a bridge, and these settings can be set at this tab. Then we go to advanced. Here there is really a lot you can set, but I haven't played with it, and I haven't missed anything. Maybe in a next video I will tell you that you can find great settings here, but I haven't found them already. So I don't know what to say for this advanced settings here, because I haven't used them. So now we are at this point. I'm going to click OK. I've set all the settings I want to set. I am going to this point so you can see it, and I say prepare to print. And now when I'm hitting prepare to print, it is actually slicing my part, and now it's done. This is how fast this slicer slices the part. And really, if you work with XYZ Wafer Pro, you would have waited for this part about, I think, 20 minutes. This part at this height would have been 20 minutes in XYZ Wafer Pro, and you saw it only took about 3 seconds in this slicer, which is actually really fast. Every support material is being showed. Everything is being showed here. Now you can see from the colors here what you are printing at what moment in time. So this is the print over time, and with the different colors you can see in the legenda here what is happening at a certain moment of time. So this green is a solid layer, this blue is the outer perimeter, this pink here is a raft, and so you know exactly what is printing on what moment. The fun thing is that you can also say, I like to see the movement. And now I can see what movements my head is making, and also how fast it is going at a certain time. So I can go up here, and every time you see the movements of my tool head. And you can see that it starts with blue. Here it starts. And blue is very slow, and that's alright, because I set it at 25% of the normal speed. So this is printing very slow. Then when we go higher, the speed increases, and when we go a little bit higher again, then you see the speed is slowing down, because here it's yellow, and yellow stands for 42 millimeters a second. And then we go to green again, which stands for 31.3 millimeters a second. So you can see that here my part is printing at an average speed of about 31 millimeters a second. Then when we go to the smaller parts, you see it will slow down, and you will see this here. Here it gets smaller, and because it gets smaller, your filament needs time to cool down, and now your printing time is slowing down as well. So this means that your print will be better at the smaller parts, because it's slowing down the print. And this is also something XYZ Wafer Pro doesn't do. So I think these are great settings. Now I can click the begin printing over USB button, and when I do that, my printer starts reacting, because I'm immediately writing this file to my printer. So I hit this button, begin printing over USB, and now this program starts communicating with my printer, and in a few moments it will say it's starting to write the file to the printer. And then you can see that my printer is going to react by raising its print bed. In the meantime, while that is happening, we can see the control panel, which is normally here at the screen of the printer, and we can see this also in the software, but way nicer, because we can see a graphical environment in which we can see the temperatures, in which we can see what G-code is sent, so we can see everything. Now what you are seeing is the building of the file towards the printer. So here you see the file growing and growing as it is sent to the printer. It's uploading the file now. This uploading is done, I think, about 1.5 times as fast as XYZ for Pro is doing this. So it's really printing the file very fast. And also uploading the file very fast. As you can see, it's building it, and you see this increase, so you know where you are. And I will speed up the video now, so we don't have to wait for the complete uploading, but the complete uploading will take about 2 minutes. And in the meantime, let me ask you, if you like this video, then please give it a thumbs up, because then I know what I'm doing it for. Also, if you're not subscribed to my channel, please subscribe to my channel, because every Thursday there will be a new video about printing with this printer, and maybe in the future also with other printers. And I will make these videos for every Thursday. Sometimes in the middle of the week I will also create another video just for fun, just because I like it. But if you like this video, give it those thumbs up, because we're waiting and this is the time to do it. Have you done it already? Thanks. And now you see the part is almost finished with uploading. So when I open my door of my printer now, you will see that my build plate will rise to the upper position. I will have to catch my camera and place it another way around, something like here. The build plate is rising to the higher position, and then the print will start well, when it's done heating. So now we can take a look at this machine control panel, which you can open by clicking on this button. Then you see the machine control panel, and this is the code which is read from the printer every time, every second, when the printer gives an update status of its settings. Also, we can see here the temperatures of the extruder and the heated bed, and we can see the axis. We can go to the G-code library. Here we can see what's coming on, and we can go to the temperature plot. Here you see the temperatures for both the extruder and the heated bed, and here you will see that my heated bed will start warming up first. So the heated bed will slowly get warmer and warmer. And here we have some jog controls. We can also control the printer in increments in the X, Y and Z direction. And I don't know why my printer is making this screaming sound, but it never does before, and now it's making all kind of screaming sounds. And they're gone now. I think I may have to lubricate my printer. As you can see, the blue line here is increasing, and well, actually this is my heated bed, which will go to 60 degrees, and when it's there, my my other setting, my extruder setting, will start raising. So it's one on one. First it will heat up the heated bed, and when it's done, then it will start to heat up the extruder. With this I will end this video. I hope you enjoyed this video. Please give it a thumbs up if you like it, and subscribe to my channel if you want to see the next video, because the next video will be all about the print I made with these settings. So I hope you enjoyed this video, and I'll see you next Thursday. Bye.